Okay, this is problem number 2. Here the problem is telling us that there is a storage tank, a very large storage tank, and it's filled with water, but it has a little hole right here. It gives us the distance from the top of the water to the place where the hole is, and it gives us the rate at which the water flows in this point. So, the first thing that I did was turning this cubic meters per minute to cubic meters per second. I just divided it into 60, and then with this, I just let it there, and then I applied Bernoulli's equation, which says that this part of the side of the equation is the top of the tank, and this part of the equation is the part of the hole. And so the first I did was assume that the pressure in this point is the same as this. This is because both they are like in contact with air, so it's the atmospheric pressure one that is acting, and I assumed that P1 was the same as P2, the atmospheric pressure. And here is another supposition, that the velocity in this point is almost zero. If we write our continuity equation, we'll see that, if we want to know the velocity in this point, we'll know that it doesn't matter what number is here. If the tank is very large, and this is divided into this very large area, it will give us almost zero. So this is our second supposition, that the velocity at this point is almost zero. Then, after these suppositions, we have our next equation. Here, here we have it, and as we want to get the velocity in the whole point, we leave velocity 2 alone, and we just do maths. Here we can take off the density, because it's the same fluid, and if we make a common factor here and divided it into this, we can simplify, and we get our almost final equation, that is that the velocity, that the square velocity in the whole point is 2 times gravity times the difference, the height, y1 minus y2. So here we have our final equation, which is that the velocity 2 is this, and we just make the substitution with the real values, real numbers, and this is the height. Because we take as y2 0 and y1 16, and we have that the speed at which the water leaves the hole is 17.71 meters per second.